Hi everyone, this is Joe and welcome to lecture 1.2 for module 4 in RAD 103. And so in this lecture we're going to be talking about distortion. Alright, distortion is any misrepresentation of an object, whether it be its size or its shape, on the radiograph. So you could almost think that magnification is a form of distortion. It's a form of size distortion. Now, as far as shape is concerned, that's usually a result of some type of misalignment of the X-ray tube, the body part, and the image receptor. So one of those is not really how it should be. And sometimes we can help that, and sometimes we can't. Ideally, with any exam, we want to have the X-ray tube or the X-ray beam be perpendicular to your plate. So if here's your plate, okay, and here's your beam, you want it to be perpendicular. You don't want any angulation. That is going to cause distortion. As far as the body part is concerned, with regards to the plate, we would like our body part to be parallel to the image receptor. Okay, so in order to minimize distortion, your body part is parallel to the plate and your X-ray beam is perpendicular to the plate. If you have any questions or problems following that, please let me know and I'll try to explain, maybe using the whiteboard or something. Now, whenever one of those criteria is not met, so in other words, if we have our body part that's parallel to the plate, but we've angled our X-ray tube so that it's no longer perpendicular, then we're going to cause distortion. And sometimes we do that on purpose. The other possibility is that we do have a perpendicular beam hitting the X-ray plate, but our body part is no longer parallel to the plate. That too can cause some form of distortion, and we'll talk about different examples of those. Now, distortion will result in unequal magnification of different portions of the same object. Okay, so whenever we have that, if we have our body part parallel to the plate, but we've got an angled X-ray beam, or the other way around, we've got a perpendicular X-ray beam with an angled body part, that is going to cause unequal magnification on different parts of the object. And there are three things that that distortion depends on: the body part thickness, the body part position, and the body part shape. So let's talk more about those. All right, so let's start with object thickness. So the thicker an object is, the more OID it's generally going to have. So if you have, let's just take a leg. The leg, let's say a femur of a 10-year-old kid versus the femur of a 25-year-old athlete. Okay, those femurs, one is thicker than the other. The one that's thicker is going to have more distortion because it's a little closer to the tube. Despite the fact that all knees are done at 40 inches, you know, the athlete is going to have a thicker leg, and so therefore it's going to have a shorter SOD, and the top of it, the top of his leg, is going to have a higher OID, and so that is going to cause some distortion. Because of the thickness, it's also going to cause more blurring because a thicker object will blur more, and that's what we see here with this little picture. Whenever you see the darker blue, that means it's blurry. So the thinner an object is, the less blur there's going to be. The thicker an object is, there's more blur. You know, and you can go on with different examples. If you want to use, someone's, an asthenic person's abdomen versus a hypersthenic person's abdomen, that's a thicker body part. There's going to be more distortion. There's going to be more magnification of those organs or the intestines that are farther away from the image plate. And because of the thickness of that person's body part, there's going to be more blurriness to it as well. So the thickness of an object can affect the distortion of the image. Now, in the last video, we talked about, is there a change in magnification depending on where it is on the image receptor? And so this is kind of a similar scenario here. If you have a thin object that has the same OID, then you're really not going to see any change, and you're not going to see any change in the shape here. However, if you have a thick object that is not underneath the center of the X-ray beam, it's out on the periphery, then you are going to notice that it does become distorted a little bit due to the X-ray beam in the thickness of the object you're x-raying. So object thickness can affect distortion when it's on the periphery of the image plate. And so that's pretty much it for object thickness. Just understand, the thicker the object, the more distortion. And you're going to have even more distortion of that object if it's not directly underneath the x-ray tube. So if it's on the periphery of the plate, that's also going to cause more distortion of that object. All right, let's talk about the object position in relation to not only the image plate, but also the x-ray tube. So let's look at this first picture here, okay? Ideally, you want to have your image plate and your object parallel to one another. And if that's the case, then you're going to get the truest representation of the shape of that image, okay? Depending on the OID, now if this arrow was as close to the image plate as possible, you wouldn't get as much magnification. Since it's farther away, it's going to end up being a little bit magnified, okay? But the shape of it is relatively intact. It's pretty true to form. However, if we angle this object a little bit, if we point it up, now what we're going to get is we're going to get a shorter object. It's going to become foreshortened. So if we measured this arrow from the tip of the feathers to the tip of the arrowhead, and we measured it compared to this, the actual image, you would see that the actual image is actually shorter because of the angulation, and it's called foreshortened. Now the opposite is true if we have an object that's parallel to the plate, and we angle our x-ray tube, then we're going to end up with something called elongation, in which case the image measures longer than the actual object of the arrow. So I've got some different examples where I can point that out to you. So whether we're angling the body part or we're angling the actual x-ray tube, that's going to lead to either foreshortening or elongation. Now, this next picture kind of demonstrates how things get a little bit more crazy when we get to the periphery of the x-ray plate. Ideally, you want to have whatever the area of interest is right underneath the x-ray source where your central ray is. Okay, that's where you're going to get truest to form. As you get to the outside edges of that, you're going to have some different shape distortion because it's on the periphery of the x-ray source. So right underneath it, you're going to get little distortion. You'll still get it if you've got a body part that's not parallel to the plate, but it's going to become even more pronounced as you get to the outer edges of the image plate. So by understanding how the body part is positioned in relationship to the tube, you'll start to develop an eye in understanding that this part's going to be magnified, or this part's going to be elongated, or this is going to be foreshortened. Okay, it'll take a little bit of practice and you'll get to see it, and it might be something to practice with or play with in the lab. But you can cause this distortion on purpose by either angling a body part or angling the tube. And I wish Bouchon did a better job at this. I wish they showed parallel arrows and then what effect it has on the image if you angled the tube rather than the body part. So for example, if you had in a tube angulation and you had this arrow parallel to the board, you would still get elongation. Okay, so I wish they had a picture of that, but hopefully you can understand that. So let's talk about some real life examples, and you have actually learned how to do one of these already. So elongation is when an anatomical part looks a little longer than normal, and you've learned how to do this by doing a scaphoid image. So if we've got ulnar deviation, we've got 20 degrees, we're pointing it right at the scaphoid, you're going to elongate that bone just a little bit. So not dramatic, but let's take a look at that. Let's see an example. So here you've got your scaphoid bone here, and here was some ulnar deviation. Now it's not dramatic, but just enough to elongate that bone a little bit. You can see that's a little bit longer than this one over here. Okay, and so we do that on purpose. We do that on purpose just so that we can see the bone a little bit better without superimposition, and in a way where we can really see the long axis of the whole bone. So, you know, for some doctors that is quite helpful. Let's look at another example, a little bit more dramatic example. Now what you're looking at here is a view of the mandible, your jawbone. All right, this is called the towns, and this has the mandible is parallel to the plate, but you have 30 to 35 degree of angulation. So that's quite a bit of angulation, and you can see how it really draws out or pulls down that mandible. And so we're able to see, this is called the ramus. The part of your mandible that goes up towards your ear is the ramus, and we're able to see that a little bit better, less superimposition than this picture here. This picture is called a Caldwell of the skull, and so we've got more true to form mandible here, but we don't quite see the ramus as well. We can see it, but this really draws it out and really elongates it so that we can see it a little bit better, and we would certainly see any type of fracture or any type of injury that occurred in the mandible there. So just some cool examples there. And then we've got an example of both foreshortening and elongation on this picture here. But foreshortening is when an anatomical part appears smaller than normal, and that would be letter C. Letter A is your normal scapula with the least amount of distortion as possible. And letter C means it's angled. So it's been angled. It's almost as if it's standing almost totally upright. I mean, I guess I could do an example. So if here's my hand, okay, and if I angle it towards the camera, you can see really the measurement of my hand is only about that much, but really my hand is really that big. Same thing could be said about this scapula that's been angled to the image receptor. And so we've got a lot of foreshortening. Letter B shows a little bit of elongation. If this is the true to form scapula and we angle the tube, then we can kind of draw out that acromion process here. You know, we can draw out, and so we can see that the body actually goes down to the very bottom of the field itself, and you don't get that with this one here. So this is elongated, this is foreshortened, and that's an example of distortion. All right, guys, and with that, I think I'm going to stop here. So we've talked about making sure that our body parts are parallel to the image receptor, that the X-ray beam is perpendicular to the plate, and by doing so, we're going to show little to no distortion, or as least amount as possible. The area of interest should be right underneath your X-ray source. If you're on the periphery, then there could be a little bit more of a dramatic foreshortening or elongation. Whenever we angle the body part, we're probably looking at some foreshortening, and if we angle the tube, then we're probably looking at more elongation. But these are all forms of distortion. So hopefully you have that under your head or under your hat. If you have any questions about any of these things, please let me know. Otherwise, I will see you all at the next video.